I have looked at my pictures from my recent climb up Greenhow Hill. This is Peak Finder's view from the top of Greenhow Hill, and looking west, as in this blue wedge on the compass here, saying you can see between about 240 and 320 degrees. Various places' names might mean more to you than they do to me. Fountains Fell South Top, Fountains Fell, which are just west of Malham Tarn. And this side of Silverdale, on the far side of Silverdale, is Pennygent. And then Plover Hill might be the north end of it, and beyond that is Whernside. So I was right, you can see Whernside from there. Great Whernside is the top end of Nidderdale. If I drag this across so that we're looking sort of northeast-ish, between maybe 10 and 100 degrees. Rosebery Topping, Highcliffe, Carlton Bank, Cringlemore, Black Hambleton even, Round Hill, Stony Ridge, and a lot of other stuff. If you look around this way, you'll notice Greenhow Hill takes up quite a lot of the foreground. But from those names, some of the same names and a few others. Rosebery Topping, 320 metres high, 66.7 kilometres away. Carlton Bank, 408, 55.4. Probably I can generously zoom in on this a little. Cringlemore, 435, 57. Just to the right of it, Coldmore, 401, 58.3. Hasty Bank, it's only 397 metres high, you might not see it, 59.5 kilometres away. Black Hambleton is the actual target, it's only 400 metres, which is not as high as these two. Higher than that. It's only 47.1 kilometres away, so it's in the foreground. To the right of it, Round Hill, 454 metres high, so it's higher than this, but it's 60.4 kilometres away. And Stony Ridge, which was in the Peak Finder thing, 433 metres, 64.2 kilometres. Westerdale Moor, 429, 66.8. And Glaisdale Moor, 432, 68.9. I'm not going to describe all the place names around Glaisdale Moor because some of them are rude. So these are bearings from where I was at Greenhow Hill, next to the water tower. It's actually marked tower just there. And this is what I was looking at, Black Hambleton, which you can see by this huge 390 metre contour line. Sorry, this 390 metre contour line, it's here up in the Cleveland Way. With a single 400 metre spot height, is quite long, like about a kilometre long on the top, and very flat on top. Which means we're looking for quite a flat hill with a high point over to its left end. Let me go to the photographs I have. It looks like that. And I've got other hills further left, including Rosebery Topping, this little one just here. Just make sure that's on screen. Yeah, it's on screen. That's Rosebery Topping, just visible past whatever's to the right of it. Trying to put all these together into a panorama didn't exactly work, but we got somewhere. Trying to put those together into a panorama really didn't work. And then I have my photos. How to make sure you're looking at the right one. This is another part of the map, just the far side of Nidderdale from where I was standing. So Pateley Bridge is just down here, and the road I followed goes up this way. This is the line of sight to the summit of Black Hambleton. You can see here it's going to the right of this summit, High Ruckles. And it's going to the left of this trig post, not that you're likely to see that, on the more sticking out the front from this ridge. All these black lines around it are fences, you can see, or walls. This wall goes up almost straight away from us, and then it comes across, sloping uphill, but has a distinct shoulder there where it doesn't continue on. There is a wall up here, just to the right of the line of sight, which then stops. There's no wall there. This is a wider field. There's another above it and a triangular one. That is the line of sight we want. And on this photograph of Black Hambleton, with that summit that's somewhere here-ish, and the steep slope down in the foreground, if I zoom in, where's the summit? Not entirely obvious. If I put a fragment of that map of Black Hambleton and cut across the line of sight and stretched out to fit, you have the flat bit where there are no contour lines, and you have lots of contour lines packed densely together. Go right back to that map, no contour lines, lots of contour lines. So that's a steep bit. These are more widely spaced, so this is less steep. So I have taken that line, right angles to that line, and pasted it onto the bottom of there, where steep part, less steep part line up with steep part, less steep part. And this line of sight points at here. So this is where that summit is. In my other file that I have open, I have a photograph taken through the hoe with that same hill in the foreground, well, in the foreground of the skyline. It's in front of this stuff in the background. And the water levels. Because the camera is focused on the skyline, the water level is a little bit out of focus. It occurs to me I should have been further back and zoomed in more. Maybe I should take 2 tape measures and go to 20 meters or 15 or 18 or something like that, if I can. Black Hambleton being wide and flat, I should be able to if I go up there. We have our water level here, and it's very obviously above that. How far above it? Well, I'll have to measure that. Draw a line across, copy that line down, count the pixels, but also measure the angle, because the camera was tilted very slightly down on the left. It is, excuse me, that's helpful, 145 pixels, but it's tilted 0.66 degrees, so that's 145.01 pixels. Because I also measured the distance from, can't see it down here, to water level, and from water level to the top there, I can measure that on screen and count pixels, calculate the angle, and get this figure, which I can then use to convert my 145.01 pixels to 0.13815 degrees. Zoom back out so you can see it all. Almost the same photograph, as in taken from the same place, not pointing quite the same direction. Very similar direction. Focused on the water level. Unfortunately, this is the only photograph I got where I actually had the water level in focus and the camera properly leveled with it, which is very annoying. Because this photograph doesn't have the top or the bottom visible. The bottom's masked by this fence post and the top's out of sight. Note to self, in future, make sure you get them in the frame, because I can't get a pixel size from this. Where it's lovely and crisp and I'll be able to get an exact pixel size, well, I'm sorry, I can't, because it's not in the picture. And this is lovely where I can draw this line across here very nicely, where eye level is. But the top of the hill, well, I just had to give it my best guess. I used the figure from the previous one, I get 0.13707 degrees. Pretty similar angle. I was pretty happy when I worked that out. Of course, I did take lots of pictures and I got several at the level, or close enough to the level that I haven't deleted them yet. So I've been through them and added more lines, and we get 0.16006, 0.20864, 0.22199, and oh dear, this one isn't actually level. If you look just there and there, a line from the far right to the near left, well, the near right is above it and the far left is below it, meaning the near end is higher in my point of view than the far end, meaning I am looking upwards. And this separation is bigger than it should be. On the others, I can't say for sure that they're wrong, so they're close enough, so try again, and I got 0.19818, I think that says. So I have my numbers. What do we do with them? Well, we have a diagram. This is not to scale, right? No way was I that far up to scale, otherwise the ISS would have been passing beneath my feet. And no, I can't see that far across the Earth. That line of sight it's more than 1,000th of the way around. It's not that much of the way around. This is just the diagram. Have the radius up to the surface and the height above it at each end. Radius up to the surface and a different height in the middle, not that it matters. The angle each side, because that's level and that's level, and they're both tipped down. So this angle is not the angle between us, but the angle between each point and the arbitrary floating centre. I can put some angles in there. Those are my angles calculated from all the photographs. And then I can do some maths with them. The map distance, 47.2 kilometres, is a fraction of a circle. It is twice this angle, twice that dip angle, divided by a full circle as a fraction of the circle, and the circumference of a circle is 2 pi r. But because I'm h up, 2 pi r plus h. Or should it just be 2 pi r? See, I'm not quite sure how it works out the distance on the map. Is it at elevation or is it at sea level? But anyway, I went with 2 pi r plus h. Rearranging that gives me that the angle is 4248 kilometres divided by pi r plus 400. Maybe just pi r. Oh, the radius is 4248 kilometres divided by the angle times pi minus 400 metres. All of that minus 400 metres. Which gives me these figures: 9864.5, 9766.2, 8447.6, 6822.6, 6480.5, 6090.8 kilometres. But those are observed, and when you're observing it, it's refracted. You have to back calculate to get geometric. I assumed 5/6, well, 6/5 refraction, because it's about 8/7 on a hot day and about 5/4 on a very cold day, and it was slightly cool but it wasn't unpleasant. I just went with assume 6/5, reverse that is 5/6. 5/6 of those numbers down the right: 8220.4, 9138.5, 7039.7, 5685.5, 5400.4 and 5075.6. Quite a spread, quite a spread. And there is something wrong with at least one of those figures because they're not in numerical order, and I've only just noticed that after I started recording. Huh. Let me just 9766.2 times 5 over 6 is 8138.5, not 9138.5. Right, that's annoying. Anyway, the average of the observed values, 7912 kilometres. The average of my calculated refracted values is wrong, and I've only just discovered that, which is incredibly annoying, because it should be 1/6 of 1000 less. 1000 over 6 is times 0 minus 1 is plus 6926.7 is 6760 kilometres. Not 6926.7, but 6760. I'll just There you go. Oh, well, if it stays in focus. There. 6760 kilometres. Whereas the proper figure for this latitude is more like 6364. So how far out am I? %. That ain't a bad result. I am happy with that.